Okay, so hi everyone, Senan this side, and in this video we are going to solve the 0 1 matrix. So what is this all about? So you are given an m cross n binary matrix. That means the element has either 0 or 1, no number otherwise. So return the distance of the nearest 0 for each cell. So basically for in this case, if you are at 0, so which is the nearest 0? That is itself. So the distance between the nearest 0 is 0 for all the elements that are 0. So even if you look into the answer is exactly the same in this case. So let's look at this test case 2. So basically for these 5 zeros, you can see that the closest 0 is itself. So the distance is 0. Now for this one, and this one, right? There is an adjacent 0 right here. For this one, there is an adjacent 0 up, left and bottom. And for this one, you have an adjacent node, or I'm saying node, but adjacent 0. So these three would be marked as 1, and for this there is no adjacent 0. So the next nearest neighbor is what? This 0, right? And it is at a distance of 1 and 2. This is at a distance 2. Okay, so as you can see, this is the answer: 0 0 0 0 1 0 and 1 2 1. That is the answer. So you know there is at least 1 0 in the matrix. That means it would eventually there would be a valid entry for each element, right? If there are no zeros, you can just maybe for some reason you can return a matrix full of -1. Otherwise, a matrix of ij is either 0 or 1. It's clear. The value of m times n is 10 to the power 4. That means the number of elements is at max 10 to the power 4. M and n individually could be in between this range. Now m is the number of rows, n is the number of columns. That is enough for us to do this question. Now okay, you might think that this could be a problem of an array, and you could even do some sort of array techniques, but the real thing here is you should understand this is not a array problem, but it's more of a graph problem. And if you see closely, you are basically trying to find the breadth first search of the, and not just breadth first search, it's a multi-node breadth first search or multi-source breadth first search. So initially you would have multiple sources. So initially, like in the normal BFS, we would pass the one of the root or one of the nodes as in the queue, basically the breadth first search. Rather than a single node, we would input all the nodes that have the value 0. And since I hope you would understand this, we have a visited array and we have to return the answer in some sort of way. And in this question, what I would do is I would not use a visited array or not use a separate matrix for returning the answer. I would do everything in place. I don't know if that is allowed or not, but obviously if you can do it in place, you can obviously store the answer in a separate array. So in that case, the space complexity would be basically the size of this, and that would be used for the queue because this is a breadth first search. So let's look at the solution, how I actually implemented this. And I get, first of all, I get the m and n, the rows and the columns. I declare a queue pairs because considering each and every node as a, each and every row comma column, each and every location as a node, I need to keep track of the row and a column, right? Every node can be identified with a pair of integers, node and a column. That is why I have pair of integers. Now these are two separate vectors that we would discuss later why we require them. It's just for checking all the nodes, adjacent nodes, up, left, down and bottom. Now what I do is, it's a multi-source DFS. What I would do is start from the nodes which have the value 0. So for every element in matrix I and j which has a value of 0, push that into my queue data structure. Fine. And I would be, after doing this, I would have each and every node which has the value 0 in my queue. Okay, so now what is this depth of 2? So for this one, what would be the depth? By depth I mean the closest 0. So after doing this, after taking all the zeros, what I can find is the adjacent ones of all the zeros, right? For these 5 zeros, the only adjacent ones in the grid are this one, and this one. So that is what I'm trying to do, and I would define the depth of this as 2, because I cannot save this as 1 because I'm not using a separate visited array, right? If you had to use a separate visited array, you could take a pair or maybe a triplet of integers denoting the row, column and their depth. I'm not taking that. What I'm taking is depth as 2. So I would mark this as 2, this as 2 and this as 2, and after that I would mark this as 3, right? So the answer is requiring us to give 1 1 1 and 2, but I would be storing 2 2 2 and 3. Why? Because the values of the matrix are 0 or 1, and if I place a value of 1, I don't know if I have visited this node or not. To keep track of visited, rather than adding 1 to this node, I would add 2 or a number more than that to keep track I have visited that node. And if the value is 1, that means I have not visited this node, and if the value is 0, I don't even consider this as I have already taken that. Now since this is a multi-source BFS, rather than popping out a single element, what I would do is I'll calculate the size of the matrix, and for the first q or first size, or let's say this size is basically n, or let's say s, let's call the size as s. So the first s elements in the queue, I would pop them. I would take out the row and column from them, extract that value of the node, and what I would do is I would check for all the neighbors. This is where this new row and new column comes in. So row plus delta row, column plus delta column. So I'm just checking this is what I increment the rows by 1 and column stays as it is. So this is for going, this 1 0 is going for one step down, for -1, and this 0 is for going one step up. For this 0 and 1, this is going one step right, and this 0 and -1 is going for one step. Basically, rather than writing this code 4 times for different rows and columns, I use a for loop, and I use dr and dc, basically delta row and delta column, to keep track of which neighbor I am visiting. Now what I do is I first of all check if I am, after changing this, after moving to this new row or new column or to this new node, am I still inside the matrix or not. This is what this is checking, if I am inside the matrix or not, right? After this I check if we are inside, then I have to check if this is 1 or not. This is 1, that means we have an adjacent one which we can mark the depth to. So if this is 1, what I say is mark this as the new depth, and I push this element into the queue. So what this is doing is, for all this 5 zeros, it is finding all those ones which are just adjacent to it, that means left, right, top and bottom. So these 3 ones are there, and I would be pushing these into the queue. So after this for loop, what would happen is I would basically have only 3 elements in my queue, that is this one, and this one. And since I marked it like this value would be what? This value would be the depth. So depth is initialized as 2. So this value would be 2, this value would be 2, and this value would be. Now what I do is I increase that, right? Now what I do is I go again this for loop, I get the size. In this case it would be 3 elements. I find out all the elements, each and every element. I pop them out of the queue. I find the row and column, basically the location of this node, and I find for all the adjacent nodes if that has a value 1, and if it is true, I update the value to the depth one. So I go, let's say I first pop out this element, I see I have this one, so this value would be 2. So I have this value as 1, that means I have not visited this yet. So what I would do is I would mark this as 3, because depth here was 2, so I mark this as 3. And now I go to, and I just pop this out. So there is only one valid node or valid new row and new column, and this was this one. 0 is not being considered because matrix have a value 1. Now I go for this node, and I see for all the neighbors the up, left and right are 0, but the bottom one would be 3 in this case. So I don't do anything, so this for loop would not result in any changes to the state. And then I pop this out, and for this one I would check this last node again. I will check top and left value is already 3 and not 1, so I just get out of this while loop. This is basically the multi-source breadth first search solution. You should understand what is breadth first search first, and then try to understand what is this multi-source thing doing. Now in the end, since this value is 2 2 2 and 3, I go through all the elements again, and if the value is greater than 1, I just subtract this again, right? So this would be 1, this would be 1, this would be 1, this would be 2, and that is what we are going to return. And this is working very well. And if you see, if submission, it beats 96.53%. Now not solution but description. If you see this, what would happen is the space complexity would be what? M times n, because at max we can store all the elements in the queue, right? This is of constant space because we exactly know what is the size, and in this case we also know the elements. And now this would take a time complexity of n square, same as this in the end, time complexity of n square, or basically m times n. This is also m times n, and this while loop will go for v plus e, right? So what is total edges? Total edges is basically this 1 plus 2. Basically you can count using permutation combination what is the exact number of edges, but the vertices would be n square, and the edges are basically finite, right? Every node can have at max 4 edges, and for n square edges we can have at max 4 n square edges. That would be the worst case because the corner elements or the edge elements are taking less edge, right? But let's say uh, for this case we would have 4n square as edges, n square as vertices, and this would be somewhere about 4n square, 5n square time complexity. Or if you add this and this, it would be some constant times n square, so the net time complexity would be big of n square. The space complexity would again be big of n square, but we are not using extra space. This is important. This is what is already provided by the caller of this function, right? So I'm not considering this space, so otherwise the only space is that I'm taking is through the queue. Also what you can do is, rather than taking a pair, you could take a vector of int and you could pass 3 elements. The first could be row, the second would be column, and third would be depth. And rather than having this single depth variable, you can just pass that value through this. So if you do that, you won't have to go through this for loop, this nested for loop. But to get a better time complexity, you would be compromising space. Exactly, rather than storing 2 elements, you are storing 3 elements. That is one thing, but otherwise the code is straightforward. The only thing you need to know this is multi-source breadth for search. What is this doing here? And I'm just doing everything in place. I'm not creating a separate answer array or separate visited array. Everything I'm doing by manipulating the values in this matrix, because we know the values in this is either 0 and 1, and that is the only reason I'm able to use this matrix itself as the visit and as the answer array. So that was the whole video about. I hope you understood this, or yep, this is a medium problem, and I think I showed you the runtime. This works, this also works. Yep. So yep, thanks for watching and see you in the next video.